In this episode, chain rule for derivatives, I'm going to break it down step by step and come up with some examples, techniques and tips on how to use chain rule. Keep watching. Hey guys, chain rule for derivatives. What is that? Chain rule is applied when you handle a composite function, composite or composition of function. When your function is made of another functions. So you have like inner function, g of x, and you have outside function, f of x. So f, g of x. Now, chain rule actually says that all you need to do is just take the derivative of outside function, leaving the inside function untouched, alone, and multiply this by the derivative of inside function. So in other words, the derivative of f prime of g of x times the derivative of g of x. This is just another notation, another way of writing the chain rule. If you had the t, and t is your function g of x. Now, just keep in mind, when you use the chain rule, you take the derivative of outside function, take the derivative. And this one gets multiplied by the derivative of inside function. So out, in, out, in. Now, let's handle this. Suppose you are given something like something raised to the power, third power, derivative. So you have power of 3. So first of all, you use a power rule. So if you are not that familiar with basic derivative rules, check out my derivative videos. You have this power. You take this power and you bring it out front as the coefficient. And you reduce this power by 1. So you decrease it power by 1. So 3 minus 1 becomes just 2. And you leave this inside part alone, as is. We are not done yet with derivative, because you have this composite function. This term gets multiplied by the derivative of inside. So you need to take the derivative of this 2x minus 1. Now, all you need to do is just clean it up, simplify it with algebra. So for the second term, the derivative of negative 1 is just a constant. It goes away, disappear like magic. So the derivative of x is just 1, so that would leave you just 2 instead of second term. So 3 and 2, they need to come together. So it gives you just 6. So this is your derivative for that function. Now, let's hit this one. 1 over 2x plus 5. So, first of all, let's just bring this bottom to the top by making it negative. So here we have like invisible, it's implied power of 1. When we bring up to the top, it becomes just negative 1. And at this point, we can apply a power rule, derivative. So a power rule says, you bring this power, negative 1, out front, so your term becomes negative. And you reduce this power by 1. So you knock it down by 1. So minus 1, minus 1. So it becomes minus 2. But because you have a composite function, You have something linear on your bottom. You have to multiply this by the derivative of 2x plus 5. So at this point, we apply a chain rule. All you need to do is just simplify. So this term becomes the derivative just 2, since the derivative of 5 is just 0, it's nothing. And the derivative of x is just 1. So instead of the second term, we would have just 2. Now, I'm going to rewrite this term, keep this negative so don't lose it. This one I'm going to rewrite as a positive power. So I'm going to bring this 2x plus 5 to the bottom by making it positive. So 1 over. And we have this 2 on top. So this is your derivative for that one. Moving on, how about this one? You have root and you have inside the root expression. Now, this is a composite function. Your function actually is made of a root, so root is your outer function. And you have something inside the root, underneath the root, which is actually quadratic, to be precise, 1 minus x squared. Apply the chain rule. The chain rule states, take the derivative of outside function. You have a root, so let's rewrite it as a power. Anytime when you encounter root, radical, something like this, so all you need to do is just rewrite it as a power to fit it into power rule for derivative. So it becomes power, a half, and take the derivative. So you bring this power out front, and you reduce this power by 1. So a half minus 1 becomes negative half. But because you have a composite function, a composition of function, so you have to take the derivative of 1 minus x squared. Gets multiplied. 1 minus x squared prime. So I'm using a prime notation, is due to Lagrange. I believe the notation for derivative. Keep going, keep simplifying. Let's tackle with the second term. The derivative of 1 minus x squared is going to be just negative 2x. Since the derivative of 1 is just 0, it's constant, 1. And the derivative of negative x squared is negative, so you have to keep this negative in front, okay? And you bring this power to out front, so negative 2x. Simplify it down. I'm going to pull this negative out front. And I'm going to rewrite this 1 minus x squared. I'm going to bring it down by making the power positive. And I'm going to rewrite this power as a root. And remember, 2x goes on top of your fraction. And these two cancel each other out. And we are left with negative x on top, root on bottom. This is your derivative for that one. Alright, my special offer, my special dish, my special meal for today. You can get maybe discount. Alright, what if you are given something ax plus b raised to the power of n? So a and b, just treat them as a constant, fixed numbers. chain rule, for sure, of course. You have something inside, power rule. You bring this power out front and you leave the inside part alone as is, untouched, and you reduce this power by 1. Gets multiplied. So the derivative of inside. This is linear function. So derivative of b is just 0, it goes away. Derivative of x is just 1. So instead of second term, you would have just a. Becomes n and a, you can combine, okay? Multiply them together, and n, whatever, a times n. So this one is the derivative for that function. I hope it helps you. I know, guys, everyone hates maths, unfortunately. But if you like my video, please click like, share with your friends, leave the comment down below, and smash that subscribe button so you will not miss my new videos. Train your brain.